Welcome to Programming for Kids with Scratch 2. I'm Mike Lehman, and thanks for joining me. This series of half-hour shows uses Scratch to introduce computer programming to kids, about 5th grade and up, and curious adults too. You'll learn all about programming in Scratch in this series. It covers loop blocks, repeat, repeat until and forever, decision blocks including if and if else, procedure blocks, variables, lists, messages, events, clones, even microphone and video webcam input. I'll create many programs including games, storytelling, drawing pictures, and programs that demonstrate important programming concepts including objects, threads, and polling. This series is all about doing and shows the creation of all working programs from start to finish. Scratch is a great first programming language and can have children very quickly creating and presenting stories and creating fun animations, all while learning valuable critical thinking skills, problem-solving skills, and the fundamentals of programming without any of the confusing and detailed syntax. Scratch presents programming commands as single blocks that are easily snapped together to make programs with very little typing. Don't let the ease of Scratch fool you into thinking that there's little here. Scratch programs can do a lot of things. Very little math is needed to make fun programs, and I give the very few equations that I'll use in a handful of about 50 challenges. Scratch is free and freely available from the highly regarded university MIT. With your web browser, you can create, share, and save your Scratch programs if you want to. You can also look online at literally millions of shared Scratch programs, and if you like, you can join the Scratch community. You can just sit back and watch this show, or you can go to scratch.mit.edu, click on the Try It Out icon, and have fun learning how to program too. All of these video challenge lessons and more are available at my ProgrammingForKids.info website and at my ProgrammingForKids.info YouTube channel. The countdown timer at the bottom of the screen shows how long until a program is first run. This show number 3 introduces if and if else blocks with 4 examples and shows the Bitmap Mode Editor. I'll get started. This challenge is an introduction to if statements. There are many times when programs need to do different things, like when a sprite walks into the edge of the stage. If and if else blocks let programs do different things at different times. This challenge has 4 examples, including a program that has a sprite walking around the stage, making turns and playing a sound. The first example will change the sprite back to its normal size if it's small. I'll use the set size command, go to looks, get the set size command. Set size to 100% sets the sprite to its normal size. Go to Help, Block Help, click on Set Size. I can see 3 examples. Set the sprite to 50%, half its normal size, to 200%, twice its normal size, and 100% its normal size. Get a couple copies of set size, duplicate, and duplicate. Change 100 to 50, change 100 to 200. When I click on Set Size to 50%, the cat shrinks, and I can see its size. Scroll down. I'll check the size variable. The size variable has the current size of the sprite. If I click on Set Size to 200%, the cat is twice as large as normal, and size is 200. I'll change it back to its normal size. For this example, I want the sprite back to its normal size when it's small. So if size is less than 100, I want to set size to 100%. Control, if the size is less than 100, operators, get the less than condition, drop that in. Size is less than 100, back to looks. I'll get the size variable. I'll click on it, drag it over, and drop it into the if. If size is less than 100, set the size to 100%. I'll add a message in there too. Have the message say 100% now. When this runs, and if size is less than 100, the 2 commands inside will run. Events. When the green flag's clicked, that'll run. And to make it a little bit easier to change the sprite size, I'll change it when the sprite's clicked on. Attach it. When the sprite's clicked on, this event handler will be called, and the size is set to 50%. I'll try it. Click on the cat. Cat changed to 50% its size, and size is 50. When I click on the green flag, size will be compared to 100. If size is less than 100, 50 is less than 100, that's true. This condition would be true, so the blocks inside will run. The size will be set to 100, and the cat will say 100% now. I'll click on the green flag. I see 100% now, and the cat's back to its normal size. If I click on the green flag again, will I get the message 100% now? If size is less than 100, 100 less than 100 is false. This condition will be false, so the commands inside the if won't be run. I'll click on the green flag. No message and no change. Now I'll try setting the size to 200%. I'll click on the set size. The cat's now twice its normal size, and size is 200. When I click on the green flag, is 200 less than 100? 200 less than 100 is false, so the if won't run the commands inside. I'll click on the green flag. It didn't say 100% now. To get this program to set the size to 100%, size will have to be less than 100. If I click on the sprite, it'll set the size to 50%. I'll click on the sprite. Size is now 50. I'll click on the green flag, and the cat's back to its regular size. I'm finished with this example now. I'll get rid of the if, the set size blocks, and the help. Don't need size anymore. Back to looks, scroll down. I'll uncheck size and it disappears from the stage. And I'm ready for my next example, where I want to make the sprite visible if the user says he or she doesn't see the sprite. How can I make the cat sprite disappear? I'll use the hide command. I'll click on hide. The cat disappears. The show command makes the sprite reappear. Hide and show. I'll attach the hide block to the when this sprite click block, and if I click on a cat, it'll disappear. I'll make it appear again. For this example, I want to make the sprite visible if the user says he or she doesn't see the sprite. In Scratch, the ask block can be used for getting information from the user. Go to Sensing, and I'll use the ask block. I'll change what's your name to can you see me? ? The answer the user gives will be in the answer variable. I'll check the variable so the answer will be visible on the stage. If the answer is no, then I want to make the cat visible. Go to Control and get the if command block. Back to operators, equals operator. If the answer is equal to no, then I want the show block to make the cat visible. I'll add a message there too. Go to looks, say hello, but instead of saying hello, I'll say now you can see me. First I'll hide the cat, click on the green flag. Now being asked, can you see me? I'll type in no, N-O. I'll click on the check mark. I could use the enter key, but I'll use the check mark. I saw now you can see me, and the cat's reappeared. What happened? The answer is no, the two characters N-O. Is N-O equal to the string N-O? Yes, that's true. So the if runs the commands inside. I'll run it again. First I'll make the cat disappear. Click on the green flag. Can you see me? I'll put the wrong answer in. I'll type in yes. When answer is yes, answer won't equal no, so it won't run the commands inside. Click on the checkbox, and the cat didn't reappear. I'll try some other answers. Click on the green flag. Can you see me? I'll answer no in capital letters, and I'll click on the checkbox. Capital No matched lowercase no. It's important to know that in Scratch, uppercase letters match lowercase letters when Scratch is comparing characters. I can see capital N, capital O matches lowercase n, lowercase o. They match, so the if command runs the commands inside. I can even mix up the upper and lowercase characters and they'll still match. I'll make the cat hide, green flag to run. This time I'll type a capital N and a lowercase o. The cat reappears and I get now you can see me. One more time I'll hide the cat, green flag. This time I'll give a lowercase n and a capital O, and that matches too. The lowercase n and the capital O matches the lowercase no. Remember, when Scratch is comparing the characters, it doesn't care whether the characters are upper or lowercase. It's case insensitive. I'm finished with this example. I'll get rid of the command blocks. I'm ready for my next example. I I want to ask what 1 plus 1 is and say right or wrong depending on what the answer is. I'll go back to sensing. I'll get the ask block. What is 1 plus 1 question mark? I want to answer again. I'll save it. Back to control. If command. If the answer is 2, I want to say right. Operators, get equals. If the answer equals 2, answer, go to looks, say, and say right. Move this a little down. When the answer is wrong, I want to say wrong. I'll copy the if, right-click, duplicate, and attach it. But how do I say when the answer is not equal to 2? I'll change right to wrong. I want the first if, that if the answer is 2, to say right, and the second if the answer is not equal to 2, to say wrong. Operators. Unfortunately, Scratch has a limited number of comparisons. I can compare for less than, equal, or greater than. I also have not available. I'll get that. Not. Answer equal to. When it's not the case that answer equals 2, that's the same as saying when answer is not equal to 2. I'll put that into the if and see what I've got. If answer is 2, it'll say right. If it's not the case that answer is 2, it'll say wrong. This might be a little confusing. I'll show a table that'll help. Boolean or logical data types have two values, true or false. A number is less than another number is either true or false. And that's true for equal, greater than, and not. Not true is false, and not false is true. 10 less than 100 is true. 10 greater than 100 is false. 10 equal 100 is false. For this program, I'm interested when answer is 2 or not 2. I'll pick a couple different values. I'll try answer is 1 and answer is 2. Is answer equal to 2? 1 is not equal to 2. This is false. Is 2 equal to 2? That's true. Is answer not equal to 2? This is not answer equals 2. Not answer equals 2. So this is not false, which is true. Not answer equals 2. Not answer equals 2. Not true is false. I'll see if that sounds right. Is answer not equal to 2? Is 1 not equal to 2? And I have true in the table. Is answer not equal to 2? If answer is 2 not equal to 2? That's false, and the correct answer is in the table. Now look at my if statements. If answer is equal to 2, then this think command will be run. If answer is 2, then that think will run. If not answer equals 2, when answer is 1, this think will be run. I hope that helps. Go back to Scratch now, and I'm ready to run it. I'll click on the green flag. The cat asks, what's 1 plus 1? I'll enter 2, and I'll hit my enter key this time on the keyboard. I got the answer right. The answer is 2. 2 equal 2 is true, so say right is run. The next if is run. 2 equals 2 is true. Not true is false. So the if doesn't run the say wrong inside. I'll run it again. Click on the green flag. What is 1 plus 1? I'll enter a 1 this time. Click on the check mark. I get wrong. 1 equal 2 is false. So say right isn't run. 1 equal 2 is false. Not false is true. So the say wrong command is run. There's an easier way to write this program. I'll use an if-else command block. I'll move the ifs out of the way, go to the control palette, get the if-else command block and attach it. I'll copy answer equals 2, So if answer is equal to 2, the blocks inside the first area will be run. I'll copy the say right and put it in. Else answer is not equal to 2, and the commands in the second block area will be run. I'll copy the say wrong and put that in. If answer is 2, it'll say right. Else answer is not 2, so it'll say wrong. I'll go back to my table and add the if-else. I'll compare the if-else with the two ifs. Answer is 2. If answer is 2, then the first think is run. Else, the answer is not 2, maybe 1. The second think is run. You can see the two ifs are a lot like the if-else, but the if-else is easier. I'll go back to Scratch and try a couple values that might be surprising. Better to see them now than on your own later on. I'll run the program. What is 1 plus 1? What if I enter 2.0? Is 2.0 going to be equal to 2? The characters aren't the same, but the numeric values are the same. I'll click the checkbox, and the cat says right. I can see the answer 2.0 matched 2. 2.0 is equal to 2, and the cat said right. If both sides of the comparison are numeric values, Scratch will compare their numeric values, not the characters. One last answer to show. I'll run the program. What is 1 plus 1? This time I'll enter TWO. Is the number 2 going to be equal to the string TWO? Click on the check, and the answer says wrong. TWO is not a number, it's a word. The characters TWO are compared with 2. They don't match, so wrong is displayed. I'm finished with this example now. I'll get these blocks out of the way. Sensing. I'll get answer off the stage. Now I'm ready for the last example. To have the sprite move around the stage, and whenever it hits the edge of the stage, the sprite should back up, turn left, and make a sound. For this example, I want to use a different sprite. Go to New Sprite, choose Sprite from Library, clicked on it, scroll down. I'll double-click on Ladybug 1. Now I have both sprites on the stage, but I only want the Ladybug. One way to hide the cat is I'll click on the cat sprite. I have the cat scripts and its commands, looks, and click on the hide block. Now the cat's hiding. Notice that both sprites have their own scripts. Right now the script for the cat's displayed. If in the sprites area I clicked on the Ladybug sprite, I get the scripts for the Ladybug. I haven't created any scripts for it yet, so it's empty. For this example, I want to move the sprite around the stage and do a few things. I'll go to Motion and use the Move command. I'll use bigger steps. I'll use 50 steps, so that'll be bigger. And I'll need a loop to make it move. Go to Control, and I'll use the simple forever loop. Drag it over, jaws open up. Now the move 50 steps is inside the loop. This loop will be very fast, and Ladybug will go right into the edge of the stage. I'll add a wait. Drop it in. Now if I were to run the loop, the Ladybug would move 50 steps and wait, move 50 steps and wait, move 50 steps and wait, and once it hit the edge of the stage, it would stay there. I want this program to have the sprite back up, turn left, and make a sound when it hits the edge of the stage. In the Motion palette, there is a command block to bounce when touching the edge, but I want to do some different things. So I'll go to Control and get the if command. Drop it in right after the move. Put the wait inside the if. I want the wait after the if. I always want to run the wait whether or not it hits the edge. To detect hitting the edge of the stage, I'll go to Sensing, and I'll use the touching condition. Drop it in the if. From the pull-down menu, I'll select Edge. Now after moving 50 steps, the sprite will check to see if it's touching the edge of the stage. If it's touching the edge of the stage, it'll perform the blocks inside. It'll always run the wait after checking. For this example, the sprite should back up, turn left, and make a sound. So how do I make the sprite back up? Back to Motion, and look at the Move command. Get a couple examples. Change the first one to be 50, and I'll change the next one to be negative 50. Moving 50 steps will move the sprite forward. Moving negative 50 steps will move the sprite backwards. I'll click on the Move 50 steps, and the Ladybug moves forward. I'll do it again, and the ladybug moves forward again. I'll click on Move negative 50 steps, and the ladybug moves backwards. One more time, and the ladybug moves back again. I'll move the command to move negative 50 steps in the if, and I'll get rid of the other command. Next, I want the sprite to turn left. I'll get the turn command, drop it in, click on the 15, and I'll change it to a full 90-degree turn. Next, the ladybug needs to make a sound. Go to the sound palette, and I'll get the play sound command. Drop it into the if. Events. Get the green flag event handler. Now when the green flag's clicked, an endless loop will be run of moving 50 steps, and if the sprite is touching the edge of the stage, the ladybug will back up 50 steps, turn to the left, and play the pop sound. After all that, it'll wait a second, and keep doing that forever. I'll click on the green flag. Ladybug's moving. There's the sound. Turn. And again. Still moving. Ladybug keeps going around and turning. I can click on the red stop sign to stop it, and the program stopped. I finished the 4 examples of introducing if and if-else blocks in this challenge, including a simple program to move the sprite around the stage. I encourage you to work with the examples and get experience working with if and if-else blocks and simple Boolean true-false conditions. Try changing the way the sprite moves in the last example. Make it do something new. Add more sounds, or add the change effect block and play with some of the different effects. Or randomly choose between a left or a right turn. Or try turning at angles other than 90 degrees. For another thing to try, add an if so that the sprite will move only if the space key is being pressed. I'll go to Sensing, Key Space Pressed. You'll want the new if that you add to use the key space pressed condition. Once you get that working, you can replace the key space pressed condition with the mouse down condition, so the sprite will move only when you press the left mouse button instead of when you press the space key. And to help more, in a future challenge, I'll have more challenging if and if-else blocks and Boolean conditions. But above all, have fun with the examples. In this challenge, I'll introduce the basics of working with the Bitmap Mode Editor. Sprite costumes and backdrop images can be edited and created in bitmap and vector modes. Watch the Vector Mode Editor challenge for vector mode details and a comparison between the 2 modes. But I will add for now that bitmap mode images may have jagged edges when compared to vector mode images. I'll create a bitmap costume image of a railroad crossing warning sign. Go to Costumes, New Costume, Paint a New Costume. I have new costume number 3, and it's blank. The Bitmap Editor has command buttons on the left to draw lines, shapes, and text, to fill, to erase, to select areas, and to duplicate. I can select colors, zoom out and zoom in, and undo and redo my changes. I want the sign's lines to be thicker. I'll slide it over. To draw a circle, I'll use ellipse, hold the Shift key down, make my circle. I can resize it and move it. I want to fill it with yellow. Fill. I want to make the black X. I'll draw with lines. One line. Other line. I don't like that line. I can undo. Try again. That's good enough for this. I want the 2 R's. I'll use text, click, capital R, click outside, I'm finished, resize it, good, move it over a little bit, finished with that. I'll show duplicate by duplicating the R, select the area. I have my copy now, good. I'll show erase to get rid of the black marks on the side, zoom in, scroll over, and erase. That's good. I'll zoom back out. Use select. Move it over. Good enough. I want a signpost to hold the sign. I'll make the post below the sign and move the sign over the post. It'll be a gray rectangle below. That's good. I'll fill it. It's solid now. I'll move the sign on top of the post. Use Select. Move it. Good enough. I'll use the brush to draw a tree. A thinner line. Select the brown. Zoom in. I'll draw a little bit of a trunk over here. Get a bit of a thicker line. Choose green and make the rest of the tree. Fill it. Good enough. Zoom back out. And there's my sign. If I decide I don't want to warn trees about railroad crossings, I could remove the tree from the sign. I can use undo several times to remove each of my actions until the tree's gone. I can redo the undos by using redo. Click on it several times, and I've redone my undos. Editing a bitmap mode image is different from editing a vector mode image. Each time I draw something, it's merged with the image. I'll get select. For example, I can't move only the tree if I want to save it. Unlike vector mode images, it's a part of the image. I'll undo this. I'm finished with this challenge. I encourage you to play with the Bitmap Mode Editor's basic commands, the buttons on the left, the color selection, zoom out and in, and the undo and redo buttons. Try creating a bitmap mode costume or a backdrop image. Experiment with it and let your creative side have fun drawing whatever you like. I'm glad you could join me. You can review these and all of my challenges at my programmingforkids.info website and on my programmingforkids.info YouTube channel. I encourage you to try the things you've just learned and explore the extra challenges I've suggested. I hope you can join me for the other shows. Until next time, have fun being creative.